Hello and welcome to Chapter 3 in Computers in Healthcare. We are going to be talking about databases. This actually starts on page 27 in the text, and we're going to actually start over on page 28. Following along with our slides, we're going to skip on down to slide number 3 to our introduction. So a database is defined as an organized collection of data, text, references, or pictures in a standardized format, typically stored in a computer system for multiple applications. Healthcare facilities collect and store a tremendous amount of administrative, financial, and clinical data. A database can assist the healthcare facility in many ways, including the facilitation of data sharing, streamlining workflow, assisting in clinical decision-making, providing information for managerial decision-making, and providing data for data analysis. Databases allow data to be stored in one place and accessed by many different systems and end users. This consolidation reduces the redundancy of data and improves data consistency because data are entered into the database once, and any screen, report, or system can access that data element. A database requires a database administrator to manage it. This DBA is the individual responsible for the technical aspects of designing and managing the database. They are responsible for designing the database as well as managing it after implementation. Alright, so let's talk about the requirements for establishing a database. The healthcare facility must develop a database that meets its needs. These needs are identified by researching the needs of the users and the external stakeholders, such as the Joint Commission, state licensing agencies, and the Centers for Medicare and Medicaid Services. The data elements stored in the database must meet the requirements of data sets. And we've talked about data sets. It's a list of recommended data elements with uniform definitions that are relevant for a particular use. And our example is the UHDDS that's used in acute care hospitals. It captures and reports the minimal data required for all inpatient discharges. And the UHDDS includes patient name, discharge disposition, date of admission, diagnoses and procedure codes, and much more. Once all of the necessary individual data elements are determined, a common data definition should be developed for each data element. As discussed in Chapter 2, this definition would be utilized to collect data consistently throughout the healthcare facility. For example, time of discharge could be the time that the discharge order is written, the time the discharge order is entered into the information system, or the time the patient walks out of the hospital. Alright, so let's talk about some database management system. A database cannot function without a database management system to manipulate and control the data stored within the database to meet the needs of the user. It controls the ability to create, read, write, and delete data stored in the database. And there are 6 database management system functions listed as follows. So we're going to go over those. Moving where data is stored in the database, managing concurrent data access by multiple users, including provisions to prevent simultaneous updates from conflicting with one another, managing transactions so that each transaction's database changes are all or nothing unit of work. In other words, if the transaction succeeds, all database changes made by it are recorded in the database. Support for query language, which is a system of commands that a database user employs to retrieve data from the database. Provisions for backing up the database and recovering from failures, and security mechanisms to prevent unauthorized data access and modification. So the parts of the database management system include data definition language, data manipulation language, data control language, and a data dictionary. The data definition language, or DDL, is a special type of software used to create the tables within a relational database, and we're going to cover the relational database later in this chapter. It translates how data are stored in the computer from the physical view, which is the physical structure of the database, to the logical view, which is the one that is understandable by the user. The data manipulation language, or the DML, is a special type of software used to retrieve, update, and edit data in a relational database. The DML accesses, makes changes to, and retrieves data from the database. And the data control language, the DCL, controls access to data within a database. And we're going to get to data dictionary here in a minute. So let's talk about natural language queries. So when you have a database and you want to search for something in your database, your natural language queries use common words to tell the database which data are needed. For example, the user may enter a query by typing, list all of the patients whose principal procedure is 0F140D3. This command would generate a list of patients who had the principal procedure. Another example could be, how many patients were discharged on October 1st, 2015? To process the query, the system searches keywords in a request in order to fulfill the request. Some information systems may allow the use of voice recognition, thus eliminating the need to type in the request. And so another kind of example of this, your natural language queries, is think about when you go to Google and you type something into Google that you want to, find information on. That's kind of similar to this. You know, how many earthquakes were there in 2014? Stuff like that. So that's your natural language queries. Then we have queries by example, and we have a couple of different ones to cover here. So a query by example is a query method whereby the user only has to point and click to choose tables and fields contained in the database. The information system then allows the user to choose whether the entries meet those criteria should be included or excluded from the query. For example, the user may choose the patient table and discharge date as the field. The user can then tell the IS to include patients discharged January 1, 2014 to January 31, 2014. Only the patients with a discharge date within that range would be included in the results of the query. All right, another example is going to be our Boolean search. Boolean search capabilities such as and, or, and not may be used in the QBE database, which is query by example, to narrow down the data to specifically what the user needs. For example, the query could retrieve patients who had a principal diagnosis of cholecystitis and a principal procedure of laparoscopic cholecystectomy. So the and is what ties it together. So you're looking for more than one thing, and you're tying it together using and, or not. If the patient had a diagnosis of cholecystitis, but not a principal procedure of laparoscopic cholecystectomy. And then we have our wildcard search. This is a truncation. So sometimes you have wildcard searches in, different kind of applications, but this is used to look for variations in the word. So for example, the user could search for patients whose admission date is greater than or before a specific date. The wildcard would be used to indicate that the query should identify data that meet the partial information provided. For example, a query of 0F140D and then the % sign would retrieve all codes that start with the specified characters, such as 0F140D3, and then so on to 4, so on to 5 and 6. And so your wildcard character in this scenario is that % sign. And then it says here, different characters may be used as wildcards in different databases. And so, for example, I'm going to use North Mississippi Medical Center as an example. Sunrise Clinical Manager, which is the electronic health record, the wildcard search is the % sign. So if I want to look up patients that have a last name starting with TU, I can enter TU and then put the % sign, and it's going to pull all patients that have last names beginning with TU. If I'm in the other system, my system that I used to manage, Sunrise Record Manager, I want to do the same thing. I do TU and I do an asterisk. So that wildcard search in SRM is an asterisk, not the % sign. Okay, so let's talk about structured query language. A common data retrieval tool is structured query language, or SQL, or SQL, the standard language for the relational database. So now we're getting into our relational databases. SQL defines data elements and manipulates and controls data. The data definition components of SQL allow the user to create tables, delete tables, and show how something is viewed. Data manipulation allows the user to add and delete rows in a table and to sort, find, and compare. Another function of the data manipulation component is to update data. SQL is the programming language that manages a user's access and what the user can do. Examples of SQL commands typed by the programmer are create table, select, where, count, and update patient. Alright, so moving back to Data Dictionary over on page 30. So the data dictionary is a descriptive list of the names, definitions, and attributes of data elements to be collected in an information system or database, whose purpose is to standardize definitions and ensure consistent use. It also helps to control the quality of data. The data dictionary improves data consistency because it ensures that fields have the same meaning and format throughout the organization. It helps create consistent data field names, data field definitions, field length, and element values. And so you can look at table 3.1 on page 30 and see how they have a data dictionary here. It has a data element with an example. So let's look at field length. So their example is the field length of the account number is 10 digits in all information systems, not 8 in some and 12 in others. So their definition for a field length is 10 digits, period. All systems. All right, moving down. The data dictionary assists in improving data quality, data integrity, documentation, data analysis, and data reuse. The data contained in the data dictionary is known as metadata. We've talked about metadata so many times now. Metadata is a descriptive data that characterizes other data to create a clearer understanding of their meaning and to achieve greater reliability and quality of information. Some of the metadata contained in data dictionary includes, but is not limited to, the following: names of elements, definition, source of data, length of field, allowable range is appropriate, valid values, access restrictions, and length of field. The data dictionary may also control if a mask is used, and if so, what form it takes. So looking at table 3.2, we see some, just an abbreviated sample of a data dictionary, and it defines any masks that can be used. And so our example here is like your date of birth. See how your date of birth has MM-DD-YYYY. And so if we just enter those 8 numbers, those 8 digits, the mask is going to actually put those dashes where they belong. Just like if you're entering a telephone number and you enter in 10 characters or 10 digits, it's going to put the parentheses around the area code, the first 3 digits, and then it's going to enter your second 3 digits, and then there's a dash, and then your last 4. And then another example of a mask could be used as a social security number. So the social security number of 1, 2, 3, 4, 5, 6, 7, 8, 9 is entered like that on a keyboard, but it appears in the system as 123-45-6789. So those are your masks. All right, so dropping down to data standards. Data standards allow us to share data in a uniform way. Data standards include data content standards and data exchange standards. These standards are created by a Standards Development Organization, or a SDO. An SDO is a private or government agency involved in the development of healthcare informatics standards at a national or international level. Data content standards are clear guidelines for the acceptable values for specified data fields. These standards make it possible to exchange health information using electronic networks. Without standards, sharing data between healthcare facilities is difficult because facilities could name and define the same data element differently. Data content standards make it possible to share information by ensuring that users interpret data in the same way. Alright, so Moving on to the second section in this chapter, we're going to move on to data modeling. Data modeling is the process of determining the user's information needs and identifying relationships among the data. The model should be based on the organization's strategic plan and should identify the data elements to be collected and the relationship between them. It contains all of the entities appropriate for the healthcare facility and shows the technical database structure to be used in the database. And there are 3 levels of data models. We have conceptual, which is not tied to a particular database model, but rather defines the requirements for the database to be developed. This conceptual data model is the basis for the logical and physical data models. And then the second is the physical. So the physical data model shows how the data are physically stored within the database. The users are not involved with this level of the database because of its technical complexity. And then that brings us to our logical data model. This is a complete representation of data requirements and the structural business rules that govern data quality in the support of the project's requirements. In other words, it ensures that the data are available and in a useful format for the intended purpose. For example, the nursing department would look at the data differently than the HIM department, and the HIM department would look at it differently than the marketing department. All right, so let's talk about entity relationship diagram. So data modeling tools used in the logical data model vary by the types of databases involved, but may include the entity relationship diagram. Data modeling generally includes the entity relationship diagram or the semantic object model. The entity relationship diagram is a common type of data modeling that focuses on relationships between entities. An entity is a person, location, thing, or concept that is to be tracked in the database. In healthcare, entities would include such items as patient, physician, and laboratory test. Each entity has attributes, which are facts or data about the entity. And so some examples of the attributes of the entity patient include their health record number, last name, first name, middle initial, street address, and continuing on, home phone, cell phone, date of birth, social. Each entity would have a unique identifier. A patient's unique identifier could be their health record number. In an entity relationship diagram, entities are linked together to show relationships between the two. And there are several types of relationships, such as one-to-one, one-to-many, and many-to-many. So an example of a one-to-one relationship is a patient and they have one attending physician. Or there's a one-to-one relationship between a lab test and its lab result. And then we have different examples of one-to-many. So a patient may have multiple lab tests. A patient could have multiple physicians outside of the attending being consultings. If I go in and see my regular physician, but they want a cardiologist to come see me, I have multiple physicians. Or, let's go backwards. A physician has many patients. So that's one-to-many. And then you can have many-to-many. So lab tests may be performed on multiple patients. All right, dropping down to data modeling tools. A number of tools can be used to create the data model. Computer-aided software engineering is designed to create many of the diagrams and other tools used in the data model. CASE can develop tools such as the entity relationship diagrams described as well as the data flow diagrams. A data flow diagram is a diagram that shows how data moves, the input, storage, and output within the database. The data flow diagram is a way to show management and other non-technical users the system design. It is also a way to introduce the overall design of the system without getting bogged down into the details. Another tool for data modeling is the use case. The use case is a technique that is used to develop scenarios based on how users will use the data and functionality to assist in developing information systems that support the information requirement. These information systems include the databases that support them. For example, a use case might be created to show how the user would retrieve information or generate a report. Specifically, it might show how to create a list of healthcare claims requiring coding. This use case identifies the data elements needed, the flow of information, and more. All right, so now we're getting into our actual database models. So the one we're going to talk most about is the relational database, and it's because it's the most common. So in the relational database, data are stored in tables. It is named for the relationships that are created when there are data elements, such as a health record number, in common between the tables. The database table contains all data related to a particular subject or concept, such as a patient, and is made up of records and fields. In the table, the data are stored in rows and columns, much like a spreadsheet. The data in a database is stored in a file. A file is a collection of digital data stored in the database. In healthcare, a file contains information on patient care, patient accounts, employee files, or another subject, and within the file are multiple records. So dropping down, the data collected in each field can take a number of formats based on the type of data. And so types of fields include the following. You have alphabetic fields that accept only alphabetic characters. Data elements of this field type include patient name and city. Then you have numeric fields. Now this is important to remember. Numeric fields accept only numbers that can be calculated. This would include charges, but would not include zip codes and the health record numbers, because you're never going to add or subtract your zip codes or your health record numbers. So if the numbers are not going to be calculated, like added, subtracted, and so on, then they should not be numeric fields. Alphanumeric fields accept alphabetic characters, numbers, or a combination of the two. Examples of alphanumeric fields include street address, zip codes, and phone numbers. And then your time and date fields contain only a date or time. And then your auto-numbering fields create a unique number that will never be assigned again. This could be the health record number or a unique number assigned to the patient visit. Before the information or data elements go into the database, the fields should be normalized. Normalization is breaking the data elements into a level of detail desired by the healthcare facility. For example, last name and first name should be in separate fields, as should city, state, and zip code. This allows the user to search or otherwise manipulate any of the data elements. And so if you read down through there, it says if the city and state were stored in the same field, the user would not be able to run reports or query the database based on state, because you would always have Tupelo, Mississippi, or Saltillo, Mississippi, or Amory, Mississippi. You couldn't search just Mississippi. Database administrators and others are able to display information about the data on screen when a user has a request for particular data. The information is requested through a query, which is a search for the data that meets specific criteria the user requests within subsets of the data. The queries sort and filter the data to display all records that meet the criteria for the user review. For example, the user could query all patients discharged by Dr. Smith in 2018. The patients could then be sorted by diagnosis, procedure, date of discharge, or other data element that exists in the database. All right, so let's talk about key fields. A key field is a field in the table that holds a unique identifier to ensure that each data entry in the database table is different. The unique identifier is generally called the primary key. In the electronic health record and other clinical information systems, this unique identifier is typically the health record number. Within the database, the tables organize the information from all records into rows and columns or cubes and use the primary key to locate the information. With the use of the primary key, such as the health record number, then all of the patient's health information can be linked together. When the primary key from one table is found in another table, the second primary key is called a foreign key. For example, the patient table would have a primary key of health record number, but the physician table primary key may also be in the table so that the patient's attending physician can be identified. Once the attending physician is identified, then all of the physician's information, such as specialty, address, and phone number, can also be retrieved. Other examples of primary keys found in healthcare are a billing number or a physician identification number. All right, moving over to our next kind of database, we have hierarchical databases. So like the name implies, it structures the data in a hierarchy very similar to that used for an organizational chart. To use the analogy of a tree, the trunk of the tree would be the starting point or the initial query by the user, and as the search narrows or goes forward, each branch of the tree becomes smaller, progressing outward toward the leaves of the tree, which represent the end point of the search. Each piece of data in the database is called a node. Pointers indicate where in this tree structure the data are stored. And so in our hierarchical database model, we have a parent-child relationship created by the relationships developed by the pointer. The relationship can be described as one-to-many. This means that a parent can have many nodes, but a child can only have one parent. The hierarchical database model is not always user-friendly because it may require developers of the information system to predetermine the queries that will be needed rather than write a query ad hoc. And ad hoc just means as needed or on the fly. You just want a quick report to find something, and it's not always easy in this model. Another disadvantage of this model is that the user must understand both the physical and logical data models. And we said earlier that physical data model was very techy and very detailed, and not everybody knows that. I sure don't. All right, next database is our network model database. It uses pointers to connect data. The nodes are called owners and members, instead of our patients and child relationship like the hierarchical database. A member node in the network database model can have more than one owner, unlike in the hierarchical database model. Now we're moving over into our object-oriented database. These handle text, images, audio, videos, and other objects. These images and other non-text items are stored as objects. An object is the basic component in an object-oriented database that includes both data and their relationships within a single structure. Each data element is called a variable. The object-oriented database uses programming tools such as Java, which is a programming language that was designed to be used on the Internet and that runs some of the functions of Internet applications. When the users access the web page, a window appears asking the user to install the Java applet, which are programs that reside on HTML web pages. Two concepts related to the object-oriented model are encapsulation and inheritance. Encapsulation is defining the characteristics of an object. For example, a lab test would have a name, a test result, time, and a date. In the object-oriented database, an object can inherit properties from another object when the characteristics are similar. This characteristic is called inheritance. An example of this is a physician and a resident physician. Both have the data elements of name, address, specialty, phone number, and others in common as they are both physicians. And then we have our last type, which is a multi-dimensional database model. So a multi-dimensional database model is used in data warehouses. The data are collected from multiple sources, such as other databases, and then summarized. This enables data analysis using a wide range of data. The multi-dimensional database is designed to quickly access this summarized data. All All right, so let's get down a little more nitty-gritty into data repositories, data warehouse, and then data mart on the next page. So we're still on page 37 in the text. Data in healthcare facilities are collected in many different systems, both clinical and administrative. The data from these information systems are frequently centralized into a single database. Two options for this single database are the data repository and the data warehouse. The data repository is an open structured database. It's not dedicated to the software of any particular vendor or data supplier, in which data from multiple information systems are stored so that an integrated, multidisciplinary view of the data can be achieved in a single source. The data repository is updated by the various information systems in real time, thus providing users with access to the most current information available. This real-time access to data is called online or real-time transaction processing. Dropping down to the data warehouse. It is a database that makes it possible to access data from multiple databases and combine the results into a single query and reporting interface. Like the data repository, it stores data from many different systems, and it includes historical and current information. Data warehouses hold an abundance of data from many different source systems and are designed for specific types of analysis, such as patient care or business. The source systems will vary depending on how the data warehouse will be used. For example, a data warehouse may be designed to look for trends in patient care. This type of data warehouse will require information from all of the clinical information systems, the financial information system, and the clinical provider order entry and other information systems. These systems would be chosen for inclusion in the data warehouse because they provide data on the care provided to the patient, the cost of that care, the test ordered, and the alerts identified. It does not include systems like the chart locator and chart deficiency system used in the HIM department because these systems have no bearing on identifying trends in patient care. And so turning over to page 38, we talk about a data mart. It is a subset of the data warehouse designed for a single purpose or a specialized use. The data mart performs the same type of analysis as a data warehouse. However, the scope of the data is narrower. The healthcare facility may choose to develop the data warehouse before the data mart, or the data mart can be developed first, or both can be developed at the same time. This order of development depends on the needs of the organization. Examples of how a data mart may be used include patient satisfaction and medical research. Patient satisfaction would not require the patient-specific information that would be stored in the data warehouse, but it would include the types of services, the nursing units, and the other basic information in addition to the patient survey or the patient satisfaction information collected. All right, moving to data mining. So data mining is the process of extracting and analyzing large volumes of data from a database for the purpose of identifying hidden and sometimes subtle relationships that would be unnoticed without the analysis. Data mining may also be called database exploration or information discovery. Data mining is important because it turns data into meaningful information. Data mining requires sophisticated software, tools, and techniques such as anomaly detection, association rule learning, cluster analysis, classification analysis, and regression analysis. So you need to know all of these. You need to know what they are, what they mean. These techniques are on page 38. So in anomaly detection, the goal is to identify data that does not follow expectations. This can be used to identify fraud and or other needs that need investigation. Association rule learning is a type of data mining that identifies interesting relationships between two concepts in a database. It may identify that patients who are treated with drug A have a better outcome than patients who are treated with drug B. Cluster analysis is identifying concepts that have traits in common. For example, monitoring the treatment practices of physicians for a specific diagnosis or procedure. Classification analysis is a method of identifying important information about the data in the database by grouping data much like grouping diagnoses and procedures. This group data can then be used in a cluster analysis described before. And then you have regression analysis. This method identifies the dependency between variables such as patients, diagnosis, patient type, and more. And in conclusion of our data mining, you have online analytical processing, or OLAP. It's a data access architecture that allows the user to retrieve specific information from a large volume of data. The use of OLAP turns the data warehouse into a decision support tool because it can analyze large amounts of data quickly. It is one of the three ways: drilling down into the data, consolidation, or slicing and dicing. Drilling down is going deeper and deeper into the data. For example, drilling down could entail looking at a cancer rate from across the country, then at the cancer rate Georgia, then in Macon, and then within the zip code of 31052. So we're just getting further and further down into the information. Consolidation refers to the aggregation of data, which is just the opposite of drilling down. And slicing and dicing is looking at the data from multiple viewpoints. For example, a healthcare facility could look at their reimbursement by payer type and then look at it by service. So if I want to look at all of my Medicare patients and then I want to look at my surgical Medicare patients, then I'm slicing and dicing my data. All right, last slide. Over on page 39, common uses and examples in healthcare and health information management. So healthcare facilities collect an abundance of data and retain these data for years. Unless the data are turned into information, they have no real value to the healthcare facility. HIM professionals work together with database administrators, other information technology staff, and the end users to ensure that the data stored within the data warehouse will meet the needs of the users. The HIM professional is often a liaison between the information technology staff and the end user. The HIM professional can be involved in data mining by defining the data to be collected and stored in the data warehouse. So examples of how data mining can be used in healthcare, including HIM, include identifying best practices in patient care, medication adverse effects, potential fraud and abuse violations, pattern of mortality and morbidity, and patterns of denials. Having this type of information enables the healthcare facility to use new information to improve services, patient care, and other functions. As more data are entered, the healthcare facility can continue to run analyses to determine if patterns appear. So again, in other lectures, I did not cover every word in the chapter. So again, it's up to you to read the entire chapter, absorb the information. I really just wanted to cover the highlights for you. So good luck and happy studying.